Hello everyone, welcome back. So in this video, we are going to understand this three sum problem from the LeetCode. Okay, so this question is very important for those who are doing FAANG preparation, right? Not FAANG, is like a MANG also. So if they are preparing, if you are preparing this right for the FAANG preparation, this is very well-known problem, and you should be aware of that. How to generate the sub arrays, you can say, right? And how you can find the triplets. Okay, so what the question is saying, that let's understand here. Very first question is saying that we have given an integer array that is called nums, and we have to return all the triplets. Okay, what is saying that we have given an integer array nums and we have to return all the triplets. What are the triplets? We have I, j and k. Okay, so three triplets we have, I, j and k. Okay, so what is saying that these triplets are nothing but array elements, correct? So the triplets means three elements, combination of three elements we need from the given array. Okay, so the index of those elements should not be equal, means I should not be equal to j, I should not be equal to k, and j should not be equal to k. All of these indices are different from each other. It means all are unique elements, unique triplets, you can say, that we are going to get from these elements. So if we choose any of these from these three elements, right? Let's suppose, so these three elements should be unique elements. I hope you understand the problem. Okay, so after that, if you do the sum, right, after that, if you do the sum of these three elements, it should come 0. I hope you understand the problem, but still if you have doubt, let me know in the comment section, do you understand or not. Okay, so what the question is saying, that we have given these elements. Let's suppose we have -1, 0, 1, 2, -1, -4 we have given. So these are the array elements we have given. Can we say that we have given these elements? Now what we need to do, very first, we have to find the triplets. Let's suppose what are the triplets are there. If we'll say, if we'll pick this one, let's suppose this is my pick 1, then we can take this one, pick 2, and then this pick 3. Okay, so if we will store this value, p1 element, p2 element, means all these three pick, means what are there, -1 plus -2 -1 and +2. So these two become -2 and this is +2, it will become 0. Understand? So these three will become triplets. So what we will do, we'll put into a set and we'll say this is my first triplet, that gives me 0. Okay, then we have another triplets that we can find from here. Let's suppose if we want to get the triplets -1, so very first is -1, then we'll take this 0, and let's suppose any of this one we'll take. Let's suppose for this one. So if this -1, 0 and +1, if we'll take, right, this here +1. Okay, this is not the -1, this is your -1. So from this one we can do the minus, right? We can do, it will give 0. So these are the two triplets, and we can see in the array given, we are seeing these two triplets we have. Okay, so how we are going to solve this problem? Very first, okay, what will be our approach to find these triplets that will give me the sum equal to 0, right? As you can see, in the note, it is also saying the solution set must not contain duplicate triplets. It should not contain the duplicate triplets. So the triplets should also be unique. Okay, so can I say, if I have this triplet, okay, let's suppose I'm talking about this one. So can I say, if we have -1, 0, 1, 2, -1 and -4. Okay, so this is the array we have given, like this we have given. Okay, so if I will very first do the sorting, how we'll do the sorting? After sorting, what the element will become? It will become -4, very first, -1, -1, 0, 1 and 2. After sorting, this is your sorted array, right? How we are doing that, that is a different thing. Just think that how if we'll sort this array element, the new array will become like this, the sorted array, right? Why we are going to do, let's suppose if I have the sorted array, the benefit is that I can use two pointers algorithm, right, on the sorted array. So we will use two pointers algorithm on the sorted array. So we'll do the sorting. Okay. Then let's suppose very first what we will do, I'll say what are the elements which is nums at we can say element I. So these are indexes. These are the indices. We can say indices 0, 1, 2, 3, 4, and 5. These are the indices, right? These are the I indices, index of the array element, right? So nums of I is less than equal to 0. What are the elements are there? So can we say that index start at where? At 0. Can we say that? And ends at where? Here. So these are the window we have where nums at I is less than equal to 0. Why I am saying that? If we have any negative value or 0 value, right? If we have any negative value and 0 value, let's suppose I'm talking about -4. Okay. If we have -4, right, it is already in the minus. So if anything we will add here, anything that will give you what? 0. Let's suppose any 4 will be available here. Okay, on this one, or the combination, any sum. Let's suppose this is sum. So if sum of two elements, you remember the two sum problem is there. So if I'll say, if I'll do the sum, two sum out of from here to here, okay, from here to here, if I'll do the two sum operation, if I apply the very first, I have already put the two sum problem, right? So what I'll do, I'll put in the comment, I will put this two sum problem that I have solved already in this playlist, right? The very first video I have put on the this playlist is two sum. Okay, you can get it from there, or I will put into the comment section. So let's suppose this element we have -4 and anything that we can get from the two sum that we call target, let's suppose. So -4 and x, whatever the two sum is gives you, if it is having, let's suppose +4, right? So -4 and there is +4, let's suppose. Okay, if both is there, it will give you 0, but only in this case is not there, that is fine. But let's suppose if it is there in between there, if somewhere is there, let's suppose I'm talking about this one, if we have here 4 is there, or or we don't have 4 here, we can take 2 here and 2 here. Okay, so these two will do the sum, it will become 4, right? It is 4, it will be 0. So the triplet will become what? Already we have picked this one, these two we will pick. Can we say that? We can say that, right? So we just need this, right? And for that we just need the sorting, right? So that we can apply this to some problem concept on this rest of the part. Very first we have picked this element, and rest of that we will apply the two sum on this one. Okay, little edge cases will be there, that is different thing, but the main logic is here that we are going to apply here. Are you with me? I think you are with me, then understand again. So we are talking about when we have -4 here, if the rest of element we can get from the two sum, our job is done. So this logic we will apply here. Let me clean it. Okay, so after sorting we got this one, and we'll pick the element as well as. Okay, so let's suppose very first when the element is at here. Okay, so now we can clean this. This is not required actually, so let me remove this one. Okay, so very first let's suppose when this is your I. Okay, so we'll create a loop that will go from here to here, from here to here, 0 to 3. Okay, so because it is a negative value, right, that will not give the contribution, it will reduce the element from the positive side, right? So our purpose is we'll only run the outer loop, right, from here to here, that it will give you the negative value or 0. Okay, means if the nums of element at I is less than equal to 0, it will give you what? The negative value or 0, that will not contribute to the sum, right? Any positive value or more than 0 we have, right, it will contribute to the sum. That will not reduce the sum. And what we required, required 0. So any part, if this part is gives you negative value and any of this part is gives you any result, let's suppose y, right? So if we'll do the x plus y, it is only gives you 0 if it is negative. If it is coming positive, right, so no chances there. There is no chances. If this is positive, then there is very less chances that we will get the 0. Okay, so what we will try, we will use this part from here to here for the outer loop. I hope you understand. Okay, so can I say that in very first, when we'll say I equal to 0, right, we will run a loop where I is at 0, right? We'll take from the two sum. If you remember, we used to take one left. So I will take a left here, where at here, right? And right will take at the last. So from here to here, we'll apply to some problem, as I told you, right? From left and right. Okay, and then we'll check the rest of element is there or not. So when I is 0, left will become what? Left will go for 1, means this is 1, right, till it will go to the 4. So it will say 1, 2, 3 and 4, means till 4 it will go. And y will stay at where? At means the right will be at 5. It will not move anywhere, just for understanding. Okay, because based on this data, because if we'll do let's suppose this is 4, right? If we'll do the sum, right, so very first the value is what? -4. If nums at -1 is there, right, it will give you some value, right? If you'll add into the 2, it will not give you the result, it will give you 1. Then again we'll apply with the -1, it will give you, we will skip that because it duplicate, but for now understand, if we'll do the sum, we'll get 1. 0 plus 2, 2, 1 plus 2 is 3, but it is not coming equal to where? If you'll do the plus of the rest of the part, it is not gives you 0. Okay, so it will run all the left to from 1 to 4 and right will stay there. Okay, means the binary search that we are two, what do you call, 2 pointers. The 2 pointers algorithm will apply left till left is less than right, will move that, right, like we will do that. I'll show you how to do that. Okay, now think when I is at where? I is at 1. When I is at 1 means, oh okay, one thing we left. Okay, so as you see, I we have started at 0, left started at where? At 1, means this is I plus 1. Understand? Then if we'll say I is equal to 1, I will start at where? At 1, means left will start at where? The next time when I is come here, let's suppose when I next time it will come here, not here. I will be started where? At here, 1. So the left will start from where? At here. Understand? So we'll say left will go 2 and we will do the sum. This is your -1, right? So -1, if we'll apply at here, this 2. So what we will say? This is -1 is coming. So -1 and -1 will not give you the result, right? Then we'll move to 0, right? -1 and 0, it will not give you the result, right? So is this I and this is your left. Can we say that? So -1 and 0, it will give you what? -1. Then we'll say this minus is already there, right? So we should move here, right? So we'll go to the 3. So -1, it will not give you the result. Okay, so it will keep moving ahead. Okay, means we can say left will go 2 and 3 index. Sorry, 2 and 3, right? And the right will remain same at 5. Okay, so when left will reach at 3, right, what we have at here? We have -1, correct? What we have at -1 we have, and we left reach at here. Okay, now think what we have at right. Right we have 2, so right is at 5, correct? So if we will reduce the right from here, what we will get? 1. So this 1 and this value, right, what we will get? And already left is at here. So if we'll take this and this, will give you what? Think 0, right? So we'll say right will go not here, it will go 5 and then it will move to less one index less is 4 that we have seen. Let me clean it here. Okay, left and right. Okay, so this we have seen. I hope you understand. Next time I will move from 1 to 2 and left will remove from here. Okay, so I raised to here. So when I raised to here, there is a duplicate element. So this element is already available here. So in this case, we'll skip. We'll not do anything when we find duplicate, right? Because the same issues will come like that. We'll skip that. So we'll skip it. We'll move to I equal to 3. Why we will do that? I'll let you know. Okay. Just for understanding, understand this. Okay. Give me 1 second. Let me clean these two. Okay. Now you think our I will reach to the next index where I equal to 3, where will reach to here I equal to 3. So only less chances are there to say that. So we say I equal to 3. So left is at only 4. Left will be at here, right? So left is at 4 and right is at where? At 5. We'll say right is equal to 5. So this is the loop that we will run. Okay. Now understand, when we are talking about I equal to 2, right? When I is at 2 here for this element, right? You can write these notes. Okay, I'll clean it here. Give me 1 second. So I was saying when I is equal to 2, right? Means this is a duplicate case. Can we say that? Duplicate case. So the duplicate case we found at I equal to 2. Okay. It means when we have -1, right? So the nums at 2 is -1. And if we'll do nums at 2 minus 1, the previous one, it will come what? Nums at 1 and it is also -1. So these two are same. When these two are same, it means if this type of condition are there, we'll skip it, right? We will skip the finding triplets. Okay, when we can say, when we'll say nums at I not equal to or equal to, okay, if not equal to, then we'll process, means nums at I minus 1. Can we say that? So this is the concept we have to see. We know how to iterate over the array, but we should also understand when we will skip it. Okay, and then we'll do the same thing. Okay, I hope you understand. Let's understand the code part. So very first, what I told you, to just do the sorting, right, of the given array. So what the array we have given in argument, we have given nums, right? So we should sort the array so that we can use 2 pointers algorithm, right? So let's suppose what we can do, we'll do arrays. Remember in Java we have arrays dot sort. On the Java 8 onwards we have given this method where you just need to pass nums, okay, the array element, it will get sorted. Why we are doing that? So that we want to use 2 pointers, right? 2 pointers, and so that we will do the sorting. Okay, let's suppose this is the triplets we have to return. So we'll say this is about triplets and equal to new array list, and we have to return this. Can we say that? And just let me return it here itself. Return here. Okay, very first we'll do these things and we will write the code here, write logic here. What I have done, very first we have to write the arrays.sort nums, then we'll do the triplets, right, and we'll define the triplets. We'll update the logic here so that once we will find the triplets, we'll keep updating at the logic time, and once we will done, we'll return it. Okay, so very first in the logic part, what we need to do, think, as I told you, we should start the very first loop, right? There is I, j and k, right? Very first we'll start I int I equal to where 0. So all the negative cases we have to run, all the negative for all the negative elements, right? Means from minus to 0 means the array element nums at I should be less than equal to 0, right? So can we say, let's suppose all the elements are negative, then what will happen? It will go to run till the all the elements. So we'll say till I is num dot length, this is the last length, it will go to the last length, right? But before terminating you just need to do what? And you apply, means there should be another condition. If nums at I, the element that we are going to see should be less than equal to what? Is 0. If it is less than equal to 0 means all the negative cases, right? And we'll say I plus plus. I hope you understand, right? So all the negative value will apply. Okay, then we need two pointers we need to iterate about that, and we need to find that, right? But I told you we will skip when the duplicate case is happening. So there is one condition we forget to say for the very first element, right? Because when we are talking about the very first element, let me show you how. So when we have the very first element, right, at here I equal to 0, when I is at equal to 0 we do not have any previous value, right? So we'll not apply this condition when I equal to 0, but we will apply for all the value which is from where 0 to 3, right? Because these are negative values or 0 means there is less contribution for the sum, right? Because we need the sum 0. So we have used I equal to 0 means there is no negative value or no previous value we have, so apply this. Then we'll say or nums at the previous value at I is not equal to nums at I. Can we say that? If this is the condition we have, means there should not be duplicate element. If not duplicate element, if any duplicate element coming, just discard it. We don't need to find the to sum, right? Because it is negative value, or you can say it's a negative value, and it when we have the two negative value it will add the more negative value, right? That is also not good. Okay, so here we'll use to sum. If you remember, to sum we will use here, where we need to pass the nums element we will pass and the current index where we have I, right? Once we have I, the current index, we can find the left and right. So this is the utility method we'll create in another method. Okay, and then we'll pass this triplet that we have created. So we will update this triplet. Once we will find, right, we'll update it and it will return it. Means another method we have to write here. I hope you understand, right? So what we need to do, we have to define the method is void because we are not returning anything, and we'll say to sum will be used, and we'll pass a very first array we have given array, and this is nothing but nums, right? And we are at index I, this is your current index, and there will be the triplets that we have here. So I'll copy here like this. Can we say that? Then what we should do, once your structure is ready, if you have already done the to some problem, right, where we have given a target, let's suppose what the target is there. Give me 1 second. So this is a to sum problem, right, where we need to find the target, right? Let's suppose we need the target 9. Okay, and this is the given array we have given, right? Let's suppose we have given 2, 7, 11 and 15. This is the array we have given, right? And we need to find to the target 9, right? So what we used to do, I have already uploaded, but let me give you a little idea. So let's suppose this is your left and this is your right, right? So we have 2 and what do you have? 7 we have. 2 plus 7 we got, right? It is equal to 9. If it is equal to 9 means we found the index. So this index and this index. So here we are returning index 0, index 1. But if we will say, okay, we find the two elements that gives you the sum of 9, right? That is this. If you have already done this logic, right? So this three sum problem is very easy for you. Okay, let's get back to here. Okay, so the logic will remain almost same. Okay, what do you need to do? We have let me give 1 second. Okay, so what we need to do here, we have to pass the nums, we have to pass index we are sending, and the triplets, right? Next, what you need to do, if you have done the two sum problem, means we need to define left index is equal to the I we have started, right? And it will start from I plus 1. Do you remember? Give me 1 second. So if you remember, we have taken array. Let's suppose I'll take a small array. Okay, this array. Okay, so if I is at here, let's suppose at 0, the left will start at where? At 1, right? And this is your left, the last element. So this is your I, this is your left, and this is your right, right? So means I is if 0, the left will start from where? I plus 1. Can we say that this is your left? Okay, and right will be at the n minus 1 length, at the n minus 1. So we'll use here the same thing. Okay, so we can say I plus 1. Okay, and we'll use the right. Okay, can we say that int right is at where? We have the nums, we'll say length minus 1, the last index. Okay, understood? Now we just need 2 pointers we have to use. We'll say left is less than right. Can we say that? Here, two things we need to do. One, we have to check the sum. Let's suppose sum will check. If we'll find the sum, some value is coming. Let's suppose 0. If value is coming 0, just for understanding, if sum is coming 0, we find the three triplets and we got the sum, right? So just you need, if sum is coming where? 0, if it is equal to 0. So what we will do, right? We found the triplet. We found the triplets, right? So update your final list. Can we say that? Then we'll say else. Write the if condition. There should be if we'll say if the sum is less than 0, one case, and there will be another case, else. When the sum is 0, it means what? The three value we were adding. What are the three values? Let's suppose nums at I we are talking about, right? Then we need nums at left we are talking about, and another we're talking about nums at right. Means if this is I, if this is J, this is K, right? So if we will do all this sum, if it will give you the sum 0, can I remove this and we'll say, okay, this is nothing but equal to 0. And we say that if the sum is coming from the nums at I plus nums at left and nums at right, if it is coming equal to 0, means we found the triplets, right? If the sum is not coming 0, then what we should do, right? Means there is two conditions left. Either sum is less than 0 or either sum greater than 0, right? So when we found 0, we found the sum is 0, it means this is the triplet we found. Okay, remove this from here. If sum is less than 0 means what? This part is coming what? Is less value, right? It means this value is 2 less, means the left is 2 less. This is 2 less value. and we need more bigger value, right? We need more bigger value, right? At nums at nums at left, right? It means what we need to do. Now you understand, the array is sorted. So if we'll keep moving in the right side, we'll find the bigger value. We'll say left plus plus. Understand? Similarly, just opposite, if the sum is greater than 0, if sum is greater than 0, this is the condition, or you can write the condition as a sum is greater than 0 right here. But I understand that the sum is 0. If sum is 0, sum is less than 0, means this condition is nothing but what? Is less than, greater than. So we'll say right minus minus, means we need right is lower value. Can we say that? Right plus plus, sum minus minus, we should understand, okay? This part means, similarly we'll say, just take this one for understanding and writing, okay? I will remove this letter. This is your right. So right is too big, too big. We need more bigger value at right, a less bigger value. It's too big. We need lesser value. Num set right. I hope you understands that we have done. How we are going to update in the list? This is the main thing we have left here, okay? So very first, we have given these triplets. We'll say, okay, triplets come here and just add here. How we are going to add? You know, Java 8 has a feature arrays dot as list. If we'll do, and we'll pass all these three value here. Okay, we just need to remove by comma. Okay, we are done. Now understand, there is one thing is left. So when nums at I, right, the left should be what? Plus plus here, and right should be minus minus. Okay, why? I will tell you. Now one more condition is left. What condition left? While left is less than right. That is perfect. This should be the condition, right? We have already seen when left is less than right. If you not right, fine. But if we'll add right, it's perfect. The else condition will match. So when left is less than right, and we'll say nums at right. If nums at right, nums are left, right? The two previous value, right? If nums at left is equal to nums at left minus 1, means this is duplicate case. Then what we will need to do? Just do left plus plus. We'll skip it. Skip triplet checking at left, at current left, and increase left plus 1. Understand? Let's try. Index, oh sorry, not index, it's a int. I'm sorry. Okay, so this code will work. I hope you understand. If you have any doubt in this video, let me know in the comment section, guys. I'll definitely help you there. Okay, let me explain you a very short. Okay, so now think that the example that we have given, do you remember? Let me try to remember. Okay, very first we have given -1. It was after sorting. Let's go with the sorting. -4 will take, then -1, then it was what? A -1, I think, then 0, yes, and then 1 and 2 we can say. Okay, 0 1 2 3, correct? This is correct. 4 and 5. So this is the array we have after sorted. After once we will do the sorting, we'll get this array, right? Now we need to find the triplets. To find the triplets, we have to run I from where? From I here 0 to this I less than equal to what? Less than equal to 0. If it is less than equal to 0, we'll keep going very first I. This is your I loop. Okay, means I will keep going here. Then we need for each I, let's suppose is I is at here, right? If I is at here, we need the left at here and right at here, right? Again, if we left will come here, we'll keep moving. That we have seen already, right? Internally, then we have to call the toSum problem, right? toSum, where we call this toSum as a utility method. Okay, so we'll take, if I is at here, so the left is where I at I plus 1. So we'll start at I plus 1 and the right will be at the same position, last index. While left is less than right, means left will start from here and will keep moving left from here to here. Okay, until it is to the last index here. Okay, till that it will go, means from here to here it is a boundary condition for him. Okay, then we'll find the sum of I, left and right. 3 value will get. Let's suppose for this one, if we'll find the sum is equal to 0, we'll say we found the triplets. Let's add the triplets here. So we'll add the triplets here. Okay, here when we do the sum equal to, right, if you see I plus 1 we are saying, right? So what we will say, we'll say we found the triplets. Okay, so at the current position, right, we'll do, once we'll update the triplets, we have to increase the left and right also, both sides. Now we will not use this one, we use the next one. So once we've got this one, we will update our triplets, then we'll move our left here and right this side. That is why we use the left plus plus and right minus minus. I hope you understand these things, right? This is basic thing. Then we have the loop we have taken, while loop, where we will use the left is less than right, and we'll say nums at left if equal to the nums at left minus 1 will increase the left plus plus, means we want to skip the triplets if we found the duplicate element. For this example, when we reach to 2, we found, oh, previous value we have already taken, which is equal to the minus 1. Okay, so don't need to do that, we will repeating the same thing. Okay, then we'll check the, if the sum is coming less value. Let's suppose we have minus 4, right? What we have? Minus 4 at where? At the sum. Then we got some value, let's suppose minus 1 we got, right? And some value from here it is coming is 2 it is coming. Okay, what the result will give you? If this is minus 4, this is minus 1, it will give minus 5. Can we say that? Then it will give you 2, it will give you the negative value, minus 3. So we don't need the minus value, we need 0, right? It means we need the bigger value here, right? So or you can say this part possibility. We know that in this, if we'll keep moving ahead, we will find the positive value, right? That is why the left plus plus we are doing. Okay, I hope you understand. And similarly for the, this will become the right if we'll need the lesser value, little lesser value. Are you understanding? It's very easy. If you have any doubt, let me know in the comment section, guys, you understood or not. And if you want any improvement in this video, let me know in the comment section. Thank you. And I saw one of the viewers said that let's start the SDE sheet, pick any SD sheet and create the video. That will help, I think, a lot of you. Let me know in the comment section you want or not. I'll continue that. Thank you. I'll see you in the next one, and please subscribe, support Expert Funda, and I'll see you in the next video.